In this session, we are going to learn about the properties of acids, the chemical properties as well as the physical properties. We see the reaction of an acid with metals, metallic oxides or metallic bicarbonates. Let us study in detail. Let us study the physical properties of acids. So acids generally sour in taste. And if we consider the physical states of an acid, some acids like boric acid, they are solid in nature, while sulfuric acid, nitric acid, hydrochloric acid in liquid form. Also, sulfuric acid is a non-volatile acid, etc. Also, let us see the color changes they brings on an indicator. It changes blue litmus paper to red. The same way, it changes the color of methyl orange to pink. And if we add the phenolphthalein solution to the acid, phenolphthalein solution, it remains colorless in the acid. Let us see this chart. Now let us see the chemical properties of an acid. The first chemical property, the reaction of an acid with metal. Acid with metal or metals. Okay. So the first example is, so we use dilute HCl react with magnesium. So always remember, when an acid reacts with a metal, it releases hydrogen gas. It releases hydrogen gas. Either you can write G here for gas, or you can put upper arrow mark here. It represents the evolution of gas. Okay. So hydrogen gas is gone out. So what is remaining? Metal react with this non-metal. So form the chloride of metal. So what is the chloride of metal? The chloride of magnesium is magnesium chloride. Sometimes we may confuse the formula. How do we find out the formula? We can make use the valencies. The valency of magnesium is 2 plus. We write 2 instead of 2 plus. While the valency of chlorine is minus 1. We write 1 instead of minus 1. Which is crisscross. So we get the formula of magnesium chloride MgCl2. So that we can write here MgCl2. So of course, every chemical equations are to be balanced. You see, 2 hydrogen, so 1 hydrogen. So make it 2. So 2 hydrogen, 2 chlorine, 2 chlorine, 1 Mg, 1 Mg. So always equations are to be balanced. Okay, let us see, when an acid reacts with a metal, it releases hydrogen gas. See another example. Diluted sulfuric acid react with iron. So as I already told you, metal react with dilute acids, it gives hydrogen gas, H2 gas, plus the sulfate of iron. Hydrogen gas gone out. So now we have the sulfate of iron. What is the valency of iron? It is 2 plus. SO4, 2 minus. The valency of sulfate is 2 minus. This crisscross, we get FeSO4. Okay. So let us see whether the equation is balanced or not. 1 iron, 1 sulfur, 4 oxygen, hydrogen 2, equation is balanced. See, here is another exception. See, a metal react with nitric acid gives zinc nitrate, a metal zinc, so zinc nitrate and hydrogen gas. But what happened to the hydrogen gas? The hydrogen gas released further reacts with nitric acid, gives water and HNO2, nitrous acid. Nitrous acid. So what happened to the hydrogen produced here? What happened to the hydrogen produced here? The hydrogen produced here oxidized to water. Hydrogen produced here oxidized to water. Who oxidized hydrogen? Nitric acid oxidized hydrogen gas to water. So we can say nitric acid is a good oxidizing agent. So you see the final product. Final product, we don't have the hydrogen gas. So it's an exception, which keep in mind, when nitric acid reacts with a metal, it doesn't produce hydrogen gas. It oxidizes the hydrogen gas produced to water, because nitric acid is a good oxidizing agent. So make sure always while writing the equations are always to be balanced. Here 2, 2, 2, 2 and 2. Okay, then only the equation will get balanced. But also you see, nitric acid can produce hydrogen, okay, with a condition. If we use a very dilute nitric acid, say 1% nitric acid, or we say very dilute nitric acid. 1% nitric acid means 99% water there. Okay, so it will produce hydrogen gas. Here to produce hydrogen gas, both the case with magnesium metal and manganese metal, nitric acid can, very dilute nitric acid can produce hydrogen gas. Also, it produce the nitrate of magnesium, magnesium nitrate, MgNO3 all twice, plus manganese, nitrate of manganese, MnNO3 all twice, MnNO3 all twice, manganese nitrate. Okay. So the condition, always keep it in mind, with 1% dilute nitric acid produce hydrogen gas with metals. The second chemical property, the reaction of an acid with metallic carbonates. See an example, sodium carbonate, Na2CO3. If by chance if you forget the formula sodium carbonate, we can use crisscross method. What is that? The valency of sodium plus 1, the valency of carbonate, formula and valency of carbonate is 2 minus. Just crisscross, you get the formula Na2CO3. Okay. So whenever you forget the formula, you can make use crisscross methods with the dilute HCl. With the dilute HCl. So always when an acid reacts with a carbonate, from the carbonate, carbon dioxide gas is released. First product, we can simply write carbon dioxide. Okay, since it is a carbonate, first product you can write carbonate. Okay, the second product, CO2 goes and one oxygen remaining here. Oxygen with this hydrogen gives, oxide of this hydrogen is, we can write water. So two products simply you got. And what is the third product? Third product is the chloride of the metal. What is the chloride of sodium? It is sodium chloride, that is NaCl. So what are the products? So carbonates plus acid gives, you get a salt, plus you get a water, plus you get carbon dioxide. So it can be a general formula. Carbonates reacts with acid, salt, water and carbon dioxide. Of course, you see whether the equation is balanced. 2 sodium, only 1 sodium. So whether we put 2 sodium. Okay, 1 carbon, oxygen 3, oxygen 2 plus 1, 3, hydrogen 1 here hydrogen 2. So you put 2 here. 2 hydrogen and 2 chlorine. So equation is balanced. See these metallic carbonates. We have lead carbonate and calcium carbonate. Lead carbonate is hydrochloric acid, lead carbonate with sulfuric acid, and calcium carbonate with sulfuric acid. All the acids we use, it is dilute acid. We deal with the dilute acids. Okay. So as I told you, since it is a carbonate, we get carbon dioxide. So hydrogen with 1 oxygen of carbonate, we get water. And the chloride of lead is lead chloride PbCl2. Okay, it is a gas. It is in the liquid form, and lead chloride is a solid. So here we get lead chloride, which is a solid white precipitate. Once such solid precipitate forms, the reaction stops there. Okay. So in the same way, lead carbonate with sulfuric acid, lead carbonate with sulfuric acid, we get the white precipitate, they are solids form, they are solid precipitate forms, so there is no further reaction, the reaction immediately stops there. Let us see. The same way we get lead sulfate, which is a white precipitate, and calcium sulfate, a white precipitate. Soon after the precipitate forms, the reaction stops there, the reaction doesn't run further. The next reaction we see, the acid reacts to bicarbonate. Bicarbonate means hydrogen carbonate, HCO3. Consider sodium bicarbonate, NaHCO3 plus dilute HCl. We get the same product as we have seen in case of carbonates. So here carbonate, there the first product you can write carbon dioxide. So hydrogen with oxygen, we get water, plus metal and chlorine, we get metallic chloride or sodium chloride. The products are same. Bicarbonate plus acid gives salt. We got the salt, water, salt plus water plus CO2. So it can be the general equation. A bicarbonate react with the acids gives what? Carbon dioxide, water and salt, or salt, water and carbon dioxide. Always make sure here too the equation is balanced. Okay. The fourth one, reaction of an acid with the metallic oxide. Okay, before going to the reaction, you must know what is the general character of a metallic oxide. Metallic oxides, we can generally say they are basic in nature, as it gives a base in water. See here, magnesium oxide, it is a metallic oxide which gives a base in water, a hydroxide compound in water. So generally we can say metallic oxides are bases, as it gives a base with the water. See an example. We have taken copper oxide or copper 2 oxide with the dilute HCl. What are the products? Okay, consider it's a metallic oxide of base. Base react with acid. Okay, a base react with acid. We have already learned the reaction between acid and base called neutralization reaction. What does it give? It gives a salt and water. Okay, don't forget this one. A base react with acid gives salt and water. Such reactions are called a neutralization reaction. So what we get the salt? Salt is the chloride of copper. Here copper chloride, CuCl2, copper 2 chloride. The valence of copper is 2 plus. The valence of chlorine is -1. Just crisscross, you will get CuCl2 plus water, H2O. Since the equation is not balanced, you are supposed to balance the equation. 2 hydrogen, 2 chlorine, 1 copper. Equation is balanced. See another equation, sodium hydroxide reacts with nitric acid. So a base reacts with an acid. That means it is also a neutralization reaction. What we get? We get a salt plus water. What is the salt here? The nitrate of sodium. So valence is sodium +1, nitrate NO3 -1. So sodium salt is NaNO3. That is a salt. Sodium salt NaNO3, and water is H2O. Check whether the equation is balanced. 1 Na, oxygen 3 plus 1 4, hydrogen 1 and 1 2 here, oxygen 3 plus 1 4, equation is balanced. See next the fifth reaction of an acid with sulphides or hydrogen sulphides or bisulphides. What happens here? We have two examples, calcium sulphide, CaSO3, and sodium bisulfite. Okay. See, since it is SO3, sulphides there, one of the product you can write SO2 gas. Both the case you can write SO2 gas. Okay, SO3 is there, sulphide or sulfur you can write SO2 gas. Second product, here hydrogen there and molecules of oxygen, of course. Okay, 2 oxygen goes, still 1 oxygen remaining there. Hydrogen with oxygen, the second product surely write what? Water. Okay, and the third product, so sulfur over, oxygen over, hydrogen over. So third product, the chloride of calcium, and this next equation, the chloride of sodium. So calcium, chloride of calcium is calcium chloride, because the valence of calcium is 2 plus chlorine minus 1. Just crisscross, you will get calcium chloride formula CaCl2. And the formula of sodium chloride, NaCl, that of course you know, NaCl. How do we make the general formula? Sulphide reacts with acid, gives a salt, plus water plus SO2 gas. So, next reaction we see how do sulphides react with the acids. So we have zinc sulphide, ZnS, plus dilute sulfuric acid, HCl. So if it is a sulfide, sulfide with hydrogen. So by looking on this equation, you can see easily identify it's a double decomposition reaction. Okay. So hydrogen and sulfur gives hydrogen sulfide H2S. It is a gas with a particular odor, particular smell. Okay, the smell of a rotten egg. Smell of a rotten egg. That is the characteristic smell of H2S, hydrogen sulfide. Okay. So the chloride of zinc, the valency of zinc is 2 plus chlorine minus 1. So if you crisscross, you get the formula of zinc chloride ZnCl2. So while valency equation 2 chlorine, so we put 2 here, 2 hydrogen, 2 hydrogen, 2 chlorine, and 1 zinc, and one zinc, 1 sulfur. Equation is balanced. Okay, how do we see the chlorides react with acids? Okay, so we have a barium chloride with sulfuric acid, H2SO4. So it is, of course, it is also a double decomposition reaction. Barium with sulfate and hydrogen with chlorine. So what we get? Barium sulfate plus HCl. Okay, 2HCl. So it is a white solid, okay, white precipitate. Okay, salt, it is a salt, of course, salt. Okay, white precipitate we get of barium sulfate and hydrochloric acid. Hope this video was helpful to make you understand the physical and chemical properties of acids. Also, it might have helped you to learn the different types of reactions of an acid with carbonates, bicarbonates, etc. If you like this video, please subscribe our channel. Thank you.